All right, 55. Calculate the 5-number summary. The mean and standard deviation for the following data set. Okay. Now, it does say the standard deviation here. Okay. Now, I'm going to ask you this question with a smaller set of data. Okay. It'll just be 5 pieces of data. Okay. I will ask you to calculate standard deviation, but it would be for a smaller set because you guys are doing it by hand. Okay. And you won't be able to use a spreadsheet. Okay, so we're going to kind of set him aside, and what I'll do is I will do the standard deviation just for the first 5. Okay, and I'll just show you how to do that. So we'll just do the first 5. He'll be his own separate question. He won't be lumped up into one. Okay. All right. So the 5-number summary is basically looks like this. You've got the min, you've got the Q1, you've got Q2, which is your median, you got Q3, and then you got your max. Okay, that is the 5-number summary. And then they ask for the average. Cool, we'll figure that out too. So this is the 5-number summary because 5-number summary is what you use to draw the box and whisker plot. Now this should have said 55. Okay. All right, now interquartile range, we'll have to, oh, these guys are out of order. But anyways, I'm jumping ahead. Let's go here. These guys are in order, it looks like, which is great, time savers. So what we'll do is we're going to start carving it up, and we can get this 5-number summary quickly now. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 pieces of data, which means I got 7 on one side, 7 on the other. So 1, 2, 3, 4, 5, 6, 7. So right there is where Q2 has to be. So I need the average. Now I'm going to calculate the average of that, or just figure out where the middle. The middle is 17. So 15 plus 19, okay, divided by 2 is going to give us 17. So we are right there. Q2 is 17. Okay? All right, now this means then that since Q2 is right here, I can actually include 19 as part of my half here. Okay, 19 is not Q2. So 1, 2, 3, 4, 5, 6, 7. That means I can go 3 on one side, 3 on the other, and this guy right here is actually Q3. Okay, this side, go right into the middle, 3, 3. It looks like this guy is Q1. That is my min, and that is my max. Okay? All right, now, if you're going to, now that's your 5-number summary. Now to find the average, just add them all up and divide by 14. Okay? And you probably just want to see if you did it right, so I'm going to do this quickly. 9 plus 12 plus 12 plus 14 plus 15 plus 19 plus 25. I have to talk when I do this stuff. Plus 34. Okay, divide by 14, and then just check for, does it make sense? Does 19, is it kind of close to our median here? Yeah, it just means that our numbers are a little bit heavier over here. So our average kind of takes us a little past 19 here, but the median is there. So that seems reasonable. And remember, our symbol for mean is X bar. In fact, sometimes people don't even call it mean. They'll say X bar. Let's get that out of there. All right, so that's 19.79, okay? Or just 19.8 is fine. All right, so now we're going to do the box and whisker plot. And what we do is, when we do the box and whisker, just make sure that you kind of start, you go from your lowest ballpark to your highest ballpark. So I'm going to go 0 to 40 because I've got my min at 3 and 35. So what that allows me to do is it allows me to start carving up my line here. Okay, it's kind of easy for me to kind of cut these in half if I have nice round numbers. Okay, so there's 5, there's 15, 25, and 35. Now that's going to help me when I actually have to graph this. Okay? All right, so what does this mean? It means that my Q, my min is 3, so that would be roughly here. Okay, and I just put all my 5 numbers are going to have a little bar here. My Q1 is 12, so he's roughly there. Q2 is 17, roughly there. Q3 is 32, all the way over here. Okay, now you can see why the average was 19.79, because Q3 is all the way over here. and then 35 is right here. Okay, now that's the 5-number summary, but to make a appropriate box and whisker, we would say we connect it like that, and that's it. And what this says is that we have a lot of variation. Okay, we do. We have a lot of variation, meaning that our interquartile range is quite large, so our ability to get an outlier is very low. Okay, do we calculate any outliers here? Yes. Okay, so we'll figure that out in 58. But right now what we're going to do is we're going to find the standard deviation. Okay, so standard deviation would look like this. All right, now we're only going to do it with the first 5 numbers. Okay, so the first 5 numbers, okay, I'm going to pretend that this is just 3, 4, 9, 12, and 12. Okay, now I need the average of those numbers. Now remember, the standard deviation symbol is this guy. Okay. All right, I'm just going to put what is he. So let's find the average. That's what I should do first. 3 plus 4 plus 9 plus 12 plus 12 equals that. Divide by 5. The average is 8. Cool. So x bar is 8. Our very first example of the standard deviation also had a mean of 8. So what we do then is we go ahead and do this. We do 3 minus 8 squared plus 4 minus 8 squared. What we're doing is we're figuring out how far we are from the average every single data point. And that's going to give us something close okay, and then I'm going to have to do this. I'm running out of space here. Okay, and all those numbers I'm going to divide by my 5 pieces of data. Okay, so I'm going to very carefully type this in. 3 minus 8 squared plus 4 minus 8 quantity squared plus 9 minus 8, which is just 1. But just for the sake of form, I'm going to go ahead and just stick with what I wrote. Don't try to get fancy. All right, I'm going to go 12 minus 8 and then square that guy. Okay, I'm going to go ahead and hit enter. I get 58. Cool. Should not have a negative number there. If I do, something's wrong. And I'm going to divide by 5. Okay, now that is what's called the variance. Okay, so the variance is good, but it's not enough. The standard deviation equals the square root of the variance. We didn't really talk about the variance, and standard deviation is much more common, believe it or not, than the variance, at least from what I remember. We're looking at a variation of about 3.4, okay? Which means that this is, if I go 1 z-score ahead, I'm going to be at 11.4. If I went 1 z-score this way, which is 1 standard deviation, I would be 8 minus 3.4, which would be 4.6, okay? And that means that 68% of my data is in between. Now, that's just the empirical rule, and I'm getting off task here. All right, for the interquartile range, what I need is, IQR is just Q3 minus Q1, okay? So I'm going to have to arrange these guys to get Q3 and Q1, all right? So I'm going to be real careful, rewrite it, and I'm going to cross it out as I'm going to cross them out as I go. Now I see the lowest number is 0.8, okay, and I'm going to put a comma, and then I'm going to go ahead and cross it out. Now the next number that I see is a 1.8, okay, 1.8. The next one up is a 2.2. Then I'll cross. So write it down, then cross it out. Then I see a 2.3. Okay, now how many do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so make sure I got 8 more to go. The next one is 2.3. Then I got a 2.9. Cross them off. Then I got a 3.0. Then I got a 3.1. Then I got a 3.1 again. Then I got a 3.2. Then I got a 4.1. And then I got a 4.5. Then I got a 5.0. Okay, so I just need Q3 and Q1, and then I'm done. So let's figure out what those. Now you can't get Q1 and Q3 until you get Q2. So we got 20 of them we counted, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I meant 12, not 20. So we got 6 on one side. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. So we're right there in the middle, okay? Now the middle of that would be the average, okay? But honestly, we don't really have to do that. We just know that the Q2 is here. What we're looking for is now I'm going to include 3, 1. He is not Q2. So 1, 2, 3, 4, 5, 6. So I need the average of these two, which is 2.25. And then the average between these two, okay, that's Q1. The average of these two is, that one I'm not going to do in my head. I'm going to do 3.2 plus 4.1, right? Yep. And then divide by 2. That's 3.65. Okay, so the interquartile range is this guy minus that guy. So 3.65 minus 2.25. The interquartile range is 1.4. All right, so this data set right here is 57. So what would the next number have to be in order to be an outlier? Okay, so this means then that what we do is we take the next number have to be the next number. The next number going forward. Okay, this over here is going to get negative for sure, but the next number going forward will produce an outlier if it is 1.5 times the IQR larger than Q3. Okay, so it would look like this: Q3 plus 1.5 times the interquartile range. Now we already figured out what the interquartile range is, and we know what Q3 is. So that's 3.65 plus 1.5 times the size of your interquartile range. So we're going to go ahead and just put that all into the calculator exactly as we have it set up. We've got 5.75. Okay, so based on all this data here, okay, if we got a number that is 5.75, it means that it's too large to be considered part of the data. Like either something's wrong or we mismeasured something. Okay, so this would have to be our next number. All right, and last one for this video: if a mean, median, and mode were the same number, what kind of distribution would you have? Well, we talked about this. That's what makes the normal distribution so special, is that we didn't even talk about. There's no such thing, first of all, as a z-score distribution, but no such thing as a skewed central. But there is a student t distribution, but that's when things look like this, okay, where they're kind of skewed to the off center, but that's for a more advanced statistics class. Okay, so 59 is A. All right, we'll stop there.